Hello, is my voice clear? Hello, am I audible? Hello, hello. Okay,
Yes, sir.
okay, fine. So let's get started with our first tutorial. So hello everyone, I am Himanshu Mishra and I am a PhD scholar in the Department of Applied Mechanics, IIT Madras. And today we will be solving a few problems that we have already covered in the NPTEL videos. So today we are going to solve problems related to the forces and moments, and then each week we will be solving a subsequent problem that we have already covered in the NPTEL videos. So this tutorial is basically designed to solve question numerical problems only. And before solving the problems, I also try to revise the concept which you might have already seen in the NPTEL class. So let's begin with the revision. So in the class, we might have seen different kinds of forces. For example, we can classify forces in many ways. For example, we can classify the forces like external force or the internal force. We can also classify force on the basis of a contact. For example, if it is a surface force or a body force. So before moving into the numerical problem, we will revise some of these basic concepts and we will revise the numerical expression that we are going to use in the problem. So let us first discuss about these kinds of forces in a very briefly manner. So in external force, what happens that the force is actually applied from the outside. So suppose you have any body, let's say you have a bar, and there will be a forces which can be applied from the outside. So these are the example of external forces. Another example of the external forces are the reaction forces. For example, if you have a applied force from the outside, which is given in the black color, what happens? It will impart a reaction from hinge to this body. So there will be a reactive forces that will be due to the hinge to the bar. And this can be given as R1 and R2. So these reactive forces and these applied forces are actually the external forces. Whereas in internal forces, what happens? These are the forces when they actually exerted inside the body shape is going to change. Okay, so it can be elongated or it can be compressive. So when there is an internal force, there will be a change in the shape of the body. There will be some kind of a deformation which will going to take place. So in this course, in engineering mechanics course, we will be talking about mostly about the external forces. We will not be concerned about the internal forces because we are not going to study how deformation going to take place, what is the consequences of deformation on the forces or the vice versa. So in most of the courses, in most of this course, we will be worried about only about the external forces and not the internal forces. Now, similarly, we can actually differentiate the surface and the body forces. So, as the name suggests, surface forces occur when there is a contact of two area. For example, this is my body 1 and this is my body 2. When the contact occurs, there will be a force generated due to this contact. and it could be a friction force or it could be a normal pressure force. So these are the example of the surface forces. And one of the most common type of force like a friction force, here in this course we will be mostly talking about this kind of a surface force, which is the friction. Now the other kind of a force is the body force. So what happens, like let's say you have some field which is due to the electric, you have a, let's say, electric field or the magnetic field, or you have a gravitational field due to a source. So this is the source which is creating a field. Okay, now you have a body which is inside this field. So due to this field, what happens? This body will experience some forces, and this is the example of the body forces. So one of the example of the body forces is weight. Okay, or a block or a particle which is experiencing a electric or magnetic field. So weight is there because the body experiences the gravitational field, and the particle can experience electric and magnetic field, force due to electric and magnetic field as well. So these are the example of the body forces. And in this course, we will be mostly talking about the body force due to the gravity. So now having classified the forces, let's discuss about how this force is implemented in the real life problems. So first, the force is actually follows the transmissibility principle. So what happens? Let's say you have a body and there is a point, some random point, and you are actually exerting a force here. And this is point A, you are exerting a force here, F, then there will be a line of action of this force. So according to the principle of transmissibility, what happens? You can actually slide this force. So you can slide this force to this point, and you can slide this force to this point. Now sliding this force will not affect the external response to the body. So if you apply the force F in a point A, the body will react, right? Now if you slide this force to point B, the body will react in the same way. And similarly, if you slide the force to, let's say, point C, the body will react in the same way. So there is no different how the response of the body will change. And this is known as the principle of transmissibility, which says that if you have a force F apply in any random point, it can slide through a line of transmissibility. So this is a line of transmissibility. Then there is a concept of co-current forces. So what happens? Let's say you have a body here, and there will be a force which is exerting on this point, and there will be a force which is exerted on this point as well. So this is F1 and this is F2. Then the line of action will be this. So the line of action of F1 will be this, and line of action of F2 will be this. So you can see there is a two line of action is actually meeting at one point. So if the line of action intersect at a common point, then these two forces are said to be co-current forces. Because you can actually slide this force. Because as we discussed, you can actually slide this force here and this force here. So the response of the system will be the same, because according to the principle of transmissibility, you can actually slide the force along the line of transmission. And you can see if the line of transmission is intersecting at a single point here, then these two forces are the co-current forces. Okay. Now, having said that, let's say you have a body here, and let's say you have a force here, F1, and there will be a force here, F2. Now, you have two forces which are exerting on the body, F1 and F2. Now, due to these two forces, there will be a resulting force which is acting on the body R. So this resulting force is the total force which is acting on a body, and it is due to the contribution. It is due to the contribution from F1 and F2. So this is the overall resultant force which is acting on the body from the force F1 and F2. So now, how to calculate the resultant force? So we will use a law of parallelogram to calculate the resultant force. So in the above case, we can write the total resultant force as the summation of F1 and F2. So this is my resultant force, which is the summation of F1 and F2. Now, in order to visualize the resultant force, it is common to actually find the component of these forces. So let's say if I define the Cartesian coordinate, because in order to study about the forces and movements, first you should define some coordinate system. Either it should be a Cartesian or it could be a curvilinear coordinates. Once you define the coordinate system, you can actually distribute the force in all the axes, and then you can actually find the overall forces in all these axes. So let me make the Cartesian coordinate system. So this is my x and y two-dimensional Cartesian coordinate, and there is a force F which is acting here. Okay. Now I can actually define the component of these forces along this x and y. So the component of force along x will be Fx, and the component of this force along y will be Fy. So if I define the angle theta here from the x-axis, then I can write my x component of force as F cos theta, and the y component of force will be F sin theta. Okay, here I am using just a trigonometric rule, and in order to calculate this angle theta, you can actually use theta equals tan inverse Fy by Fx, and we can actually calculate this magnitude of this force by Fx squared plus Fy squared. Just to be sure that these expressions are valid only for the Cartesian coordinate we are talking about. Okay. So in a given two-dimensional Cartesian coordinate, we can actually define the component of force at every coordinate here along the x and y. So along the x-axis, my contribution from this force, from force F will be Fx, and the contribution of this force F along y-axis is Fy. And we can actually calculate at the direction at which this force is acting, which is theta, from this relation. Once you get to know about Fx and Fy, you can actually calculate the overall force, which is capital F. Okay. Now this component of force can be used to calculate the resultant force as well. Because we will be concerning about the resultant force. Because if you have a body, there will be infinite many forces which can act. Okay. You have a body, and there will be many forces which are acting on this body in any random direction. So what happens? You need to actually calculate the overall result due to all these forces, and which could be given by the resultant force R. So since force is a vector, this resultant force is also a vector, you can actually write the component of this resultant force as well. Rx and Ry in the Cartesian coordinate system. So in order to visualize this, let me again make a Cartesian coordinate. So here I have x, here I have y. And now let's discuss about the resultant and the component of resultant forces, how they are actually look in the Cartesian coordinate. Suppose I have a force F1 which is acting here. This is my force F1, and there will be a force F2. So this is my force F2. And due to these two forces, there will be a resulting force. This is my resulting force. So this part is my F1x. This part is F2x. Okay. This part is y component, and this part is y component of F2, right? Then the resultant force will be in the x-axis is Rx, which is this, and in the y-axis it is this Ry. So these are my component of resultant forces. You can see the projection here, right? So in the x-axis, the contribution from F1 will be this part, and contribution from F2 is this part. And it is easy to visualize. Similarly, in the y-axis, the contribution of F1 will be this, and contribution from F2 will be this area. So in order to find the resultant force, we will be using the expression that we have looked. The resultant force will be given as F1 plus F2, right? Now we have discussed earlier that we can actually write the component of each force along the coordinate axis. So I will be writing the component of these forces. So it will be Fx, F1y, j cap plus F2x along the x and F2y along the y-axis. And I can, since my resultant force is a vector quantity, right? So I can take the component of resultant forces as well. So I can write the resultant force as R1x, I cap, R2, R1y, j cap equal to, and here let me club x component forces and y component forces along with each other. So it will be F1x, I cap, or F1x plus F2x along the x-axis, and F1y plus F2y along the y-axis. So along my x-axis, I can write the magnitude R1x equal to F1x plus F2x, and R1y, it can be just Rx and Ry. Ry equals to F1y plus F2y. So using the same definition, we can actually write Rx as summation of all the forces in the x direction, which is exactly given by here, and Ry as summation of all the forces in the y direction. So my resultant force in the x-axis is the summation of all the forces in the x-axis, and my resultant force in the y-axis is the summation of all the forces in the y-axis. Okay, so having discussing some basics, let's solve the problem. And if you have any doubt in the after the problem, then you can ask. You have any doubt until now? Okay, then let's begin with solving problems. So I will start with an easy problem, very fundamental problem, and gradually I will try to increase the difficulty a bit so that we can actually grab more concept from the problems. So we will be using these expression only, which we have discussed here. This all these expressions which we have discussed now in the problems. So let's look the first problem. So here in this problem, we have given three different kind of forces, F1, F2 and F3. And actually we need to calculate the component of these forces. So now we will see that how to find the component of these forces by different. So there are different ways actually mathematically. I mean the concept is same in all the methods. It's just mathematically there are different ways to calculate it. Overall the concept is same. So we already have seen how to find the this component of the forces. So if we have given any force F and we have a Cartesian coordinate, then we can just use the trigonometry to find the Fx and Fy. So let's say how we can do that in a multiple ways. So let's first talk about force F1. So we have given the force F1 as a 600 Newton. And we need to find the component of this force. So if I define the Cartesian coordinate x and y here, then this will be my x and this will be my y-axis. Okay, and this is my F1. And now I need to calculate the contribution of F1 along the x-axis and along the y-axis. So as we have discussed, it will be Fx1, F1 cos theta, which is my F1 is 600 Newton, so it is 600 Newton multiplied by cos theta. Theta is 35. Okay, so it's cos 35. So my Fx1 will be, so if you calculate this, you will get 491 Newton. Similarly, you can calculate the contribution of F1 in the y-axis. So it will be Fy1, F1 sin theta equals 600 Newton multiply sin 35. So your Fy1 will be, if you calculate this, you will get 344, yeah, correct, 0.14 Newton. Okay. So we have calculated the component of forces along x and y axis. Now let's consider force F2. And in order to calculate the component of this force, let me draw the Cartesian here. This is my minus x axis and this is y axis. Okay, so it's just I have drawn here minus x and this is minus y. So now I have to calculate the contribution of F2 along x and along y. But instead of angle here, we have given the ratio of triangle. You can see here, we have given here 4. We have given here 3. So we have given a triangle and we have given the ratio of their sides. Yeah. So as per short here, like you can actually calculate the angle theta of this triangle by using the trigonometry rule, or just you can use the ratio of the sides. So we already used the trigonometry here. So now I will, for this part, I will not use the trigonometry because I already shown the problem by using the trigonometry here. So by the Pythagoras theorem, we will calculate this, the ratio of this side, which is 5. Okay, so it will be 3 square plus 4 square under root, so you will get x equal 5. So this side will be 5. Okay, so you can actually calculate the angle like Shaurya has done, and it come out to be a 37 degrees. Or the other way is you can just use the sides of this triangle. So you have a force F2 here, which is 500 Newton, and let's say you need to calculate the x-axis, contribution of the x-axis. So what you will do here, so this is your, wait a minute, yeah, this is your known force F2, and you need to consider this part, right? So you will consider two sides. For example, I have a triangle here. This is F2, which is given, and this is F2x, and this is F2y. So I will consider this part, these sides of the triangle. So I can write as F2x equal to F2 4 by 5. So since you can see that the direction of F2 is in the negative x-axis, so I'm writing here minus. So it is minus 500 multiplied by 4 by 5. So it will be F2x equal to minus 400 Newton. Now in order to consider the y component, you have to choose this side and this side. So by choosing sides and using the trigonometry, I have F2, which is 3 by 5. So it will be 500, 3 by 5, and it come out to be 300 Newton. So F2y will be 300 Newton. Okay. So if you have given the triangle, you can use the sides as well to calculate the components. Okay, right. So as of now, first we have used the trigonometric angles theta to calculate the components. Then we use the sides of the triangle to calculate the components. Basically, both are the same thing. It's just the mathematical technique we use little different, but eventually both are the same things. But now in some problem, what happens? You have not given the ratio of side. You actually given the dimension here. So you have given the dimension 0.3 meter, and you have given this distance 0.2 meter from the origin, and here it is 0.4 meter from the origin. So you have given the distances. Now when you have given the distances, then you can actually find the angle first. So first you need to find the angle theta. Once you get the angle theta, then you can actually find the component of this force F3. So this is your force. Here let me make a triangle here. We already know about this force, which is F3, and we need to find the angle. Let me define the angle alpha here. So we already know this side, which is 0.4 meter, and this side is 0.2 meter. So we already know the sides, so we can actually calculate the angle. So by using the trigonometry relation, I can define tan alpha as 0.2 by 0.4. So it will be alpha equals tan inverse 0.2 by 0.4. So my alpha will be, when you calculate this, it will be 26.6 degrees. So this angle alpha come out to be 26.6, right? So let me make the triangle here. So this is your F3, this is F3x, and this is F3y, and this is alpha. So now in order to calculate the component F3x, it will be F3 sine alpha. Okay, because you need to calculate this. So this divided by this will be sine alpha, which is F3, or let me write the force. Magnitude of the force is 800 sine 26.6 degrees. So F3x will be 358 Newton. And on the same page, F3y will be F3 cos alpha. So it will be 800 cos 26.6 degrees. So your F3y will be 716 Newton, approximately this. And you can see this, the direction of forces is in the minus y direction. The minus y direction, so it will be a negative sign. This will be a negative 716 Newton. So it's a bit easy problem. We just need to calculate the components of different kind of forces, and we actually use three easy methods. First, we use the trigonometric angles to find the component, which is pretty obvious and straightforward. Then we use the ratio of triangles to calculate the components. And then since we have given the distance of both horizontal and vertical sides, we actually use this distance to find angle. So you can actually find angle here, alpha, or you can also find the angle here. You can also define some angle theta here. You can find any of the angles. And by finding the angle, these equation will get changed. So for example, if you define angle theta here, this is our angle theta, then this will get changed. So it will become F3 cos theta, and this will become F3 sin theta. And theta will be different. So if this is 26.6 and this is 90, then by law of triangle, you can actually calculate theta, which will be 90. Sorry, the law of triangle says that 26.6 plus 90 plus theta equals to 180 in the Cartesian coordinate. So theta will be 180 minus 90 plus 26.6. So it will give you the theta angle. So that you can use here. So you can find any angle. My point is you can find either alpha, or you can actually find theta, and based on that you can actually calculate the component. So any doubt? Okay, so let's move to the next problem. So in this problem, the magnitude of the resultant force acting on the bracket is to be 450 Newton, directed along the positive u axis. Determine the magnitude of force F1 and its direction. Fine. So in this problem, apart from calculating the components of the forces, we also need to consider the resultant forces. And we saw that the resultant forces in the x direction is the summation of all the forces in the x direction, and the resultant force in the y direction is the summation of all the forces in y direction. And the question says that there is a resultant force along this axis, R. Right? So since resultant is a vector force, you can actually find the component of resultant force. You have a vector R, which is 30 degrees from vertical horizontal axis. So you can actually calculate Rx and Ry. Okay. So once you calculate Rx and Ry, you can actually substitute here the value of Rx and Ry, and you can actually calculate the different component of force Fx and Fy. Right. So this is the way we can do. So first let's find the component of every force, each and every forces. So we have F1, we have F2, we have F3, and we have overall resultant force as well. So let's make a table. So these are my X components of forces, and these are my Y component of force. So we are doing the same thing that we have done earlier in the previous question. So my F1x will be, so you can see the angle it is making from the vertical axis. Okay, so this is my angle phi. And if I want to know the force in the x direction, which is this one, then my F1x will be F sine phi. And in the y direction here, it will be F cos phi. F1y is F cos phi. Now my F2 will be 200 Newton. So F2 in the x direction is given as 200 Newton. And F2, so let me put F2x. And F2y is 0 because the F2 is completely in the x direction. Therefore, there is no contribution of F2 in the y direction. Similarly, I can write F3. So here I can use the law of triangle that we have used earlier. So in the x-axis, I have to consider this side and this side, right? So it will be 5 by 13. So 260 multiplied by 5 by 13. So if you solve this, you will get 100 Newton. So this is F3x and F3y will be. So now in order to calculate F3y, you need to consider this side, y-axis, and this side. So by using the law of trigonometry, ratio of this to this, it will be F3 12 by 13, which is 260 12 by 13. So it will be 240 Newton. So now only the remaining force we have is this reaction force. And we can take the reaction force, component of this reaction force from this triangle. So you can easily see that the Rx is cos 30 and the Ry is sin 30. So this is sin 30 and this is cos 30. So Rx is R cos 30, which is 450 cos 30. It will give me 389.7 Newton. And my Ry is 450 sin 30, which is 450 by 1 by 2. So it will give me 225 Newton. Okay, so now you can see that we actually take the component of all the forces, F1x, F2x, F3x. Yes. So this will be a negative. F3y will be negative, and remaining forces will be positive. So now we have taken the component of all the forces here, F1y, F2y, F3y, and Ry. Now as per the relation here we have seen my Rx will be the summation of all the forces in the x direction, and Ry is the summation of all the forces in the y direction. So now let's use this relation because the we need to find the two quantity. We need to find the F1 magnitude of F1 and we need to find the phi. Okay, so whenever there are two unknowns, you always need two equations. So here we have two equations. The first equation is this and the second equation is this. This is your first equation. This is your second equation. Because we have two unknowns, when you have a two equation, then only you can solve for two unknowns. And it's a simple mathematical practice. For example, let's say you have x minus a equals 2, then you can, and a is the unknown scalar, then you can actually calculate x as 2 plus a. But if you have two unknowns, x and y, then you need one more equation to calculate x and y. We are using the same principle here. So since we have two unknowns, we need two equations to find these two unknowns. So my first equation is Rx equals summation of Fx. So I can write Rx equals summation of all these forces. Okay. So my Rx will be 389.7 equals to F1 sine phi plus 200 plus 100. So this is my equation 1. And my equation 2 will be Ry, which is the summation of all the forces in the y direction. So my Ry will be, it is actually 225 Newton equals to summation of all these forces. So it is F cos theta, F1 cos theta, sorry, phi, F2y is 0 and F3y is minus 240. So this is my equation 2. So now we can solve this equation 1 and equation 2. So my equation 1, let me rewrite it. Okay. So if I divide equation 1 and 2, I can actually calculate this angle. It will be 10 phi and F1 will be divided, it will got cancelled, plus 300 minus 240. So here I will get solving this, I will get phi, which is equal to 10.9 degrees. So now I can substitute the phi in any of this equation. So let me substitute in equation 1. So I have here 389.7 equal F1 sine 10.9 plus 300. So it is 89.7 equals F1, and here I multiply 0.189. So on solving this, 89.7 divided by 0.189, I will have F1 as 474 Newton. So this is my F1, which 474, and my phi come out to be 10.9 degrees. So just to be recap here, we have given a different component of forces here, F1, F2, F3, and the resultant force. We have given the magnitude of the resultant force, and we have also given the direction of the resultant force, which is along this direction U. And then we need to find the F1 and this angle phi. So first we actually write down all the components of forces of F1, F2, F3, and R along the x-axis and y-axis. Then we use this equation. We use the resultant force in the x direction equal to the summation of all the forces in the x direction and resultant force of y direction, which is equal to summation of all the forces in the y direction. So we had two unknowns, F1 and phi. So we use these two equation. We solve this equation together to calculate F1 and phi. So any doubt? So even in this question, we have used the similar concept that we have used in the previous one. We first found the components of all the forces, and then we use this equation. Additional thing is we have used these equations to calculate the unknowns. So any problem? Any doubt? Yeah, we cannot actually write like this. So one way is you can actually solve this problem like you have 225 plus 240 equals F1 cos phi. So you actually write this equation in terms of phi or F1. Let's say I write this equation in terms of F1. So I will get cos phi here. So this is my F1 now. Now I can substitute the F1 here. So it will be 389.7 equals sin phi, and in the bracket plus 300. So in bracket I will substitute this expression, which is 225 plus 240 divided by cos phi. So it will be 389.7 tan phi, some quantity in the bracket, plus 300. So you will get 89.7 tan phi multiply this quantity 225 plus 240. Then you can actually get this phi. So let's look similar problem. So the next problem is very much same. So we will be writing the components and then we will be using those components to find the unknowns. So in this question, determine the magnitude of force Fa and its direction theta, so that the resultant force is directed along x-axis and has a magnitude of 1250. So it's a same problem. So in this question, we have given that the resultant is along the x-axis. So my resultant force will be equal to Rx because Ry equal to 0. Because if my resultant force is along the x-axis, there will be no resultant force which is acting along the y-axis. And the magnitude of resultant force is 1250, which is my Rx is 1250 Newton. And we need to find force Fa and Fb. Sorry, we need to find force Fa and angle theta. We have already given force Fb, which is 800 Newton. So now you can see that you have already given Rx. So if you compute the components of this force along the x-axis, you can actually easily find the component of this force Fa. But in order to calculate this theta, you need another equation. So we need to calculate the component of force in the y direction also, so that we can again use two equations to calculate the two unknowns. So let's use first equation, Rx equal to summation of forces in the x direction. So my Rx is 1250 equals Fa, and this is your theta. So it will be sine Fa sine theta. This is actually Fa x component of Fa plus 800 cos 30 degrees. So this is the x component of force Fb, which is 800. So you will get 125. So I can actually calculate this. So here we have Fa sine theta equal to 557.17 Newton. So this is my equation 1. Then we can use second equation, Ry, which is the summation of forces in the y direction. So my Ry is 0 because the resultant force is in the x direction. All the resultant force is in the x direction. So there will be no resultant force in the y direction. So it will be 0 equals to summation of force in the y direction. So it will be 0 equals to Fa cos theta and the minus 800 sine theta. So here you get 0 equals Fa cos theta minus 400. So Fa cos theta equals to 400. Okay, so now you have equation number 1 and you have equation 2. Again, you got two equations, you have two unknown. Then you can use these two equations together to find unknown. So this time we can actually divide. So we can actually divide the two equations. So it will be sine theta by cos theta equals 557.17 divided by 400. So it will be tan theta equals 1.39. So your theta will be tan inverse 1.39 and this theta will come out to be 54.3 degrees. Then you can use this theta in either of this equation, either in equation 1 or 2. Let's say I'm using in equation 2, so I will get Fa cos 54.3 degrees equals to 400. So FA will be 400 divided by cos 54.3 degrees. So it is 400 divided by 0.583. So it will come out to be 686 Newton. So your FA is 686 Newton and your angle theta is 54.3 degrees. So it's the same problem like before. You have two unknowns FA and theta and you use two equations. Again, you use this Rx equals to summation of Fx and Ry which is equal to summation of Fy. And then you use these two equations and the condition in the question as well, which says that the resultant force is along the x-axis, and we have already given the magnitude of resultant force, which is equal to Rx because it is completely in the x-axis. Then using this condition, we can actually able to solve these two equations together to find theta and unknown force. So, any question now? Okay. So let's move to the next concept, which is the movement. So again, this is the same problem. So this problem you can solve by yourself. So you can either take a screenshot or I will upload this PDF into the Google Drive. It is the same problem that we have solved previously in the last equation. You can use the two equation Rx equal to summation of forces in the x direction and Ry which is equal to summation of forces in the y direction. You just take the component of these two forces and then you calculate the magnitude and the angle of the forces here. So it's the same problem. Just try it by yourself. Otherwise, I will solve this problem by myself. If you have any doubt in this question, it's the same problem. So try this problem by yourself. So let's move to the other concept. So we have until now we have seen that there are multiple component of forces, different kinds of forces which are acting on the body, and this produce the resultant forces. And the resultant forces itself can be divided into a multiple component of force Rx and Ry. So we know what force does. So if you apply any force to the body, it will move in the same direction. Okay, so the tendency to move the body in the direction is one of the application of the force. The other application of the force is that it can also rotate the body. So for example, let's say here you have a lever and you are actually try to impart some force here with F, and this is fixed. So when you apply some force here, this actually can rotate in either of the direction depending on where you actually applying the force. So to quantify this rotational tendency, we actually define the movement M. Just a minute. So movement is a rotational tendency of the body, which is due to the forces and the distance between the forces and the point where the body is moving. or the line along which the body moves. So in order to quantify the movement is defined as force multiplied by perpendicular distance. So one of the important concept of movement here is you need two integrants. The first integrand is force and the second integrand is perpendicular distance. So for example, this is the direction of force. Its perpendicular distance is this. This is your perpendicular distance, which is d. So this perpendicular distance and along with the force F is actually cause the movement. In the vector notation, you can actually define the movement as r cross F, where r is the positional vector and F is the force vector. So whenever you have given a question, first the easy way is you always try to actually find the perpendicular distance of the forces. For example, let's say you are given a body here. So let's say this is your body and there are multiple forces which are acting. And this is point O. Okay, so now you need to calculate the moment at point O due to these multiple forces. So first, you always try to figure out what is the perpendicular distance. So for example, for this force, let's say F1, this is my perpendicular distance. So this will cause some movement because it has a finite f and it has a non-zero perpendicular distance. So this force will create a movement about f, this point O. So you can actually imagine the movement. So the force is exerting in this way. So the movement will go this way along point O. So this is the direction of movement due to this force F1. Now let's say this is your force F2 and the perpendicular distance is this. Now from point O there will be no perpendicular distance of force F2, which means the movement due to this force will be zero because there is no perpendicular distance from point O to this force F2. There is a parallel distance, right? But there is no perpendicular distance from point O to force F2. So the movement due to this force will be zero. Now let's say this is your force F3 and this is your point O. Now you can actually define perpendicular distance from F3 to O, which is let's say D3. So this is the perpendicular distance and this is the force which is acting. And the direction of force you can imagine about point O is this. Force is acting in this direction, so it will go down like this about point O. So there will be some movement because the perpendicular distance is non-zero and the force F3 is non-zero. And you can visualize the direction also. It is so you can just visualize from the direction of force. It is how it is revolving from point O. It is going in this direction, in the clockwise direction. Okay, and same thing you can actually do for F4 and F5. It has the perpendicular distance D4 and D5 and it has the direction clockwise about point O. So F3, F4, F5, they have a clockwise movement. F1 has the counterclockwise movement, right? Because this F2, sorry, this is F1 and this is the perpendicular distance from F1 to point O, and you can see it is rotating about counterclockwise through point O. This is your point O. It is rotating counterclockwise through point O. So the direction of movement from F1 is counterclockwise and the direction of movement from forces F3, F4 and F5 are clockwise, and no movement from this F2 force occur because there is no perpendicular distance at all. So whenever you need to find the movement, first figure out the perpendicular distance. So when you figure out the perpendicular distance, you can actually get one more thing. You can actually define the direction of the movement, which is again very important because the movement is a vector quantity. So you need to define the direction as well. So first you will get whether the movement is there or not. And if there is a movement, what is the direction of it? So this you can actually easily identify once you define the perpendicular distance. Okay, but in many cases what happen in some problems, it is very difficult to define the perpendicular distance. So in that case, you can actually use this vector identity or this cross product. So then what you use this overall position vector and you use the force vector. So when you use the position vector and the force vector, you are actually considering all the distances: perpendicular distance, parallel distance, perpendicular force, parallel force. I mean, you are actually considering all the component of force, all the component of distances. But since you are actually taking the cross product, by taking the cross product, what happening? So from the mathematics that you have learned in school and in your first year, the cross product actually between two vectors, let's say a and b are my vector, the cross product is actually defined by ab sine theta. Okay, theta is the angle between these two vector a and b. So if this is my a, this is my b, and this is theta. Okay, so if my vector a and vector b are parallel to each other, this theta will be zero, so cross product will be zero, right? So what this cross product is doing, you are actually considering all components of position and force vector, but this cross product filtering out the perpendicular components because the parallel components are zero. Cross product make sure that the parallel component of A and B are zero. So what it is doing, it is filtering the perpendicular component for you. It is actually taking all the component, perpendicular component as well as the parallel component. But it is actually, but the definition of the cross product says that this component should be zero. So you are actually left with only perpendicular component. So in the case when you cannot able to figure out what is your perpendicular distance, you don't need to worry. You just use the whole vector, whole position vector and complete force vector, and you take the cross product of it. Then by taking the cross product, you will already actually getting the perpendicular component, because cross product work only when two vectors are not in a parallel direction. They can be of any direction but not parallel direction. And if the direction is perpendicular, let's say this is vector A and this is vector B, they are perpendicular 90, which means the theta is 90, which means this sine theta is 1, and which means that the magnitude of the cross product will be AB, which is the highest magnitude. So this is what this expression is doing. So first step is determine the perpendicular distance and then see whether the moment is zero from that force is not. If zero, then ignore that force. And if it is not zero, moment is not zero due to the force, then calculate the direction. I mean, just judge the direction, whether it is counterclockwise or clockwise. And then you can assign the sign, any sign to clockwise direction. You can either assign positive sign to the clockwise direction, or you can assign negative sign. But you need to make sure that if you assign the positive sign to the clockwise, then you should assign negative sign to the counterclockwise direction. Similarly, if you assign minus sign to the clockwise, then you should assign plus sign, opposite sign to the counterclockwise direction. Okay. So first decide the perpendicular distance, then decide whether the moment is zero from that force or not. And if it is not zero, then assign the distance and the sign. Then take the overall moment. Okay. And if you cannot able to figure out the perpendicular distance, then you should use the whole position and whole force vector and take the cross product of it. And it is a simple cross product that you already know how to use, because it's a basic quantity. So now let's see the Varignon's theorem. So it says that the moment of the moment of force at any point. Suppose this point is experiencing some moment m. So the moment of any point at P is equal to summation of all the moments. So there will be a multiple forces which are acting here, and each are creating movement on this point. So the moment due to this force, the moment due to this force, and the moment due to this force is equal to the net movement around this random point P. So it says that the total movement around point P is a summation of all the movements. Okay, and this movement are created by different forces F1, F2, and F3. So you can actually sum the movement. So what you need to do, you need to actually calculate movement from each forces. Then you can sum all this movement to calculate the total movement around some random point P. Okay, so this is the expression that we will be using in most of our calculation to find the moments, right? So if you have any doubt, you can ask. Otherwise, it will be much more clear when we solve the problem. Okay, then let's solve one example problem. So this is a easy one problem, and we will try to solve this problem again by multiple methods. So the concept will be the same. We need a perpendicular distance and the force to find the moment. So we will be using these single concept and try to solve by multiple ways. So here we have defined the force, which is 600 Newton. We have given the direction, and we have actually need to find the moment about point O, and we have given the distance is 2 meter, which is the distance OA, and let's say this is point B. So my OB is 4 meter. Okay, so let's find just a minute. So let's find the moment due to the force 600 Newton. So as I told that you first need to figure out the perpendicular distance. So the perpendicular distance of this force. So this is my line of action, and the perpendicular distance of force 600 Newton from point O is this. This is my perpendicular distance D. And now we need to figure out this distance. So the distance will be given as, you have d, and it can be given as, just a second, and be like this, and so this can be written as 4 cos 40. So this is my angle 40 here. So it could be 4 cos 40, and then plus this distance. And this could be, this is parallel to this one, right? And this is perpendicular. And if this is my 40, this is 2 meter, and I need to found this one, this distance, which is this. So this distance is 2 sine 40, and this distance, this one, this is actually, if I took this triangle, then this will be 4 cos 40. So my d will be 4 cos 40 plus 2 sine 40. Okay, this is my d, this plus this. So it will be 3.06 plus 1.285. So d will be 4.35 meter. So this is my perpendicular distance from this force. So then I have a force, I have a perpendicular distance from point O to that force. Then I can directly use the formula of moment. So the magnitude of moment will be just force multiply. Remember, this is not a cross product now because I am dealing with the magnitude. So it's multiply, not a cross product. So it will be force multiply by a perpendicular distance. So it will be 600 multiplied by 4.35 meter. So my moment will be 2610 Newton meter. So this is my moment. So this is one of the way, because as we have discussed, first we need to figure out the perpendicular distance, and then once we figure out the perpendicular distance, we need to make sure if force F is creating moment. So force F is non-zero, the perpendicular distance is non-zero, which means it will create a moment. And since we are dealing with the magnitude of the moment, we just uh, use the expression moment, which is force multiplied by distance. So both are the scalar quantities. Therefore, I'm using the term multiply here, and it come out to be 2610 Newton meter. But sometimes, as we have seen in this problem as well, that sometimes defining the perpendicular distances can be a troublesome. Like even here, it is little trouble because you need to make a several triangles to find the component here, to find the component of these distances. And here we need to make this triangle in order to calculate this distance. So by calculating this distance and adding together, we actually calculate D. And it is a little complicated, but you don't need to always follow this method. The another method is you have given the force 600 Newton in some, which is in some direction. You just calculate the component of this force, Fx and Fy. Okay, so when you calculate the component of force, then there will be a movement. You have to check if there is a movement due to force Fx and Fy. And if it is there, then you can use the Varignon's theorem that we have seen above. You can calculate the movement due to each force, and then you just add the overall movements. So you just calculate the moment due to Fx, let's say it's dx, and moment due to force Fy, which is dy. And then the overall moment at point O will be Fx dx plus Fy dy. Okay, so here we use the Varignon's theorem. So now the advantage here is that since we have calculated the component of the forces, defining the perpendicular distance dx and dy will be very easy because it could be either horizontal or it could be a vertical distance. Unlike in the previous case where the perpendicular distance is complicated, defining perpendicular distance is complicated and we use multiple triangles to determine the component here. Here the perpendicular distance will be either horizontal or a vertical line. For example, for force Fy, the perpendicular distance is this, which is 2 meter. So here dy is 2 meter. And for Fx, the perpendicular distance is this, which is 4 meter. So here dx is 4 meter. And now you can see that you can easily define the perpendicular distance, Fx and Fy, for Fx and Fy. You just need to, what you did, you just first define the component of this force and you can easily define the perpendicular distance of these component forces because it's very easy now. So now you can check what is the direction of the movement from force Fx and Fy. So you need to calculate a movement about point O. So you can just imagine the force is going around point O like this. So this is clockwise direction about point O. And similarly force Fy going like this. Again in the clockwise direction about point O. So the direction of a movement from force Fx is clockwise and from force Fy will be clockwise. Okay, and I can assign a clockwise movement as a positive movement. You can do negative or positive, anything you can do. Here I am assigning the positive sign to the clockwise movement. So in the second approach, we are actually calculating the movement due to the component of the forces. So first we need to find the component of force, Fx. This is my angle 40. So my Fx will be F cos 40. So my Fx will be 600 cos 40 and Fy will be 600 sin 40. So Fx will be 460 Newton, and my Fy will be 386 Newton. Okay, so now the moment, summation of moment will be given by, sorry, the overall moment at point O will be given by summation of all the moments. So it will be mx plus my. So it will be fx dx plus fy dy. So my fx is 460 and dx is this 4 meter. This is a perpendicular distance from fx to O plus 386 multiply dy is 2. So it is 1840 772. So you will get roughly the same answer. You will get the same answer, 2612 Newton meter. Okay, so you see, you will approximately you will get the same answer. So in earlier one, you got 2610. Here I got actually 459 some decimal place, and here 385 some decimal place, and therefore I get little overhead value. But you will get the same answer if you consider this decimal places and use here, take the multiplication, then you will get the same answer, 2610 here. So you see that by using the another method, by using the Varignon's theorem, you will actually arise to the same moment. So in the first principle, or in the first case, we use directly, we actually identify the perpendicular distance of some randomly aligned force. We found that it is a little tricky to calculate the perpendicular distance, but we managed to calculate the perpendicular distance, and we just use the simple formula, force multiplied by perpendicular distance, to calculate the moment. Then in the second case, we first find the component of forces, because it's very easy to find the perpendicular distance from the force components. And then we use the Varignon's theorem that the overall moment is just a summation of all the moment due to the forces here, to calculate the moment. Now you can again use one more trick here. So basically, this is only for concept understanding. In most of the problem, you will be using either method 1 or method 2. But just for the concept, let's consider the line of action of this force. Okay, so in the beginning of the lecture, we discussed that you can actually slide the force. So this is your y-axis, and this is your x-axis. So you can actually slide this force along the line of action. So this force can actually slide here, 600 Newton at an angle 40, or you can actually slide this force here, 600 Newton from 40 degree at the horizontal axis. So you can actually slide the force here or here. So let's say you slide the force at point C. This is your point C and this is your point D. You slide this force to point C, because you can do that according to principle of transmissibility. You can slide the force along the line of action and it will not affect the system. So you slide the force to point C. So now you are trying to calculate the moment, because now this is the force, this is the same force here, and now you need to calculate the moment about point O. So how will you do that? So now you can again take the components, take the component of this force here, which is Fx, and this is Fy. So now you can see that there is no perpendicular distance for Fx, 2.0. So the contribution to a moment from Fx is 0. there will be no movement due to force Fx because there is no perpendicular distance from point O to Fx. But there is a perpendicular distance from force Fy to point O, and it is this. This is a perpendicular distance, right? This is my perpendicular distance. So let's say this is t2. So now you can, so now there will be a moment due to force Fy, but there's no moment from force Fx. So the moment at point O will be given by Fy multiplied by d2. So your Fy, you already have calculated the Fy, which is 386. So this is our Fy 386, and now you need to again calculate the d2, the perpendicular distance. So this is 2 meter. We already know this distance, but now we need to consider this distance, and we have already have a triangle here. So this is 4 meter, and we need to consider this distance. We already know this, so we can easily use the trigonometry rule. So d2 will be 2 meter plus 2 meter plus this one, this distance, which can be given by 4 cot 40. So this is angle 40. 2 meter by 4 cot 40. So when you calculate, you will get d2 as 6.77 meter. So the moment at point O will be 386 multiplied by 6.77, which will give you 2610 Newton meter. So again you will get the same moment, 2610, here also 2610, and here also you got 2610. So we use 3 different approaches to arrive at the same moment at point O. And similarly you can actually transfer the force here also. And you can see that the moment due to force Fy will be 0, and there will be a moment due to force Fx. And you have a perpendicular distance, this Fx, from Fx. So this is your Fx, and this is your Fy. And there is no perpendicular distance from force Fy to point O. So the moment from Fy will be 0, and there will be a moment from Fx only. And you need to define the perpendicular distance, let's say d3. And you will, once you define the d3, once you calculate the d3, you will get the same answer. And in the previous, the same thing happened. The moment due to Fx is 0, and there is a moment due to only Fy, and you need to calculate d2. So we calculated d2, and we actually calculated moment m0 after calculating the perpendicular distance d2. So in this question, in order to calculate the moment, we use 3 different concepts. First, we directly define the perpendicular distance and use the formula F multiply D to calculate moment. Then what we did, we actually defined the component of force in the x and y direction, because it's very easy to define the perpendicular distance of this component Fy and Fx force, because it will be either vertical or horizontal line, which is very easy to calculate. Then we use the Varignon theorem, which says that the moment is the summation of all the moment from all the forces, and we calculate the moment. So this method is very easy. It's a little lengthy because first you are calculating the component of force, then you are using Varignon's theorem. So basically you are using 2 concepts here. And in the third one, you actually use a concept which we actually discussed in the early class. I mean, at the beginning, that you can use the principle of transmissibility. You can actually slide the force along the line of action, and in this way you found that if you use the component of force, then the moment due to Fx is 0, and you will have a moment only from Fy. So you calculate the perpendicular distance from Fy, and then you use the moment. And here also you don't need to use the Varignon's theorem because you are directly getting the moment. If Fx, moment due to Fx is non-zero, only then you need to consider the Varignon's theorem. So any doubt in either of these approaches? You can use any of the approaches in which you are comfortable at. The only thing you need to be sure that first you need to define the perpendicular distance, then you need to ensure if the force is zero or not, if force oh sorry, the moment is zero or not from the force, and if moment is not zero, then define the direction of the movement. So in this problem, the direction of movement was clockwise direction from both fx and fy. So any doubt? Okay, then let's solve few more problems related to it. So in this one, we need to find, we have given the force F1 and F2 and F3 here, and we need to find the moment about point A. So we need to find the moment about this point A. So it's a straightforward problem. We need to find this quantity. So first consider all the forces. So first consider point F1. So F1 is along the x-axis. So we don't need to actually calculate its component because it's already along the one component axis. So F1, there is no perpendicular distance because it's acting on that point itself. So there is no perpendicular distance. So the contribution from F1 will be zero. There will be no movement from this force F1. Now let's consider force F2. There will be a component of force Fx and Fy. That's it, F2x and F2y. Now there will be a perpendicular distance from F2x to point A, which is 2 meter. So there will be a contribution of a movement from F2x, but there is no perpendicular distance from F2y to point A. It's a parallel distance. It is not a perpendicular distance. So from force F2y, the contribution to the moment is 0. So again, this will not be here. The moment will be occur due to this force only, F2x. Now again, we can find the component of this force, F3x, and here we have, this is F3y, and here we have F3x. Again, you can see no contribution from F3x because there is no perpendicular distance, but there is a perpendicular distance from F3y to point A, which is 8 meter. Okay, so only forces which are contributing to the movement are F3y and F2x, and rest all the forces have zero contribution to the moment. Now you figure out which forces are contributing to the moment. Now you need to figure out the direction of the moment. Okay, so the direction of F2x you can visualize. So this is the direction of force F2x, and you can visualize about point O. This will go revolve like this. This will revolve the counterclockwise direction. Similarly, F3x, the direction of F3x is this, and about point O, it will revolve again in the counterclockwise direction. So both the movements are revolving in the counterclockwise direction, and I'm assigning the counterclockwise direction as the positive direction. So my moment at point A will be F2x, perpendicular distance which is 2 meter, plus F3y, and the perpendicular distance is 8 meter. So I need to find the F2x here. So it is making angle 45 from the horizontal. So it will be F2 cos 45. So this is my F2x. multiply by 2 plus F3y is this. It's making angle 30 from the horizontal axis. So it is F3 sine 30. This is my F3y multiply by 8. So this is this, and F2x is this. And we have given F2 and F3 as 80 and 40 respectively. So it is 80 cos 45. So this is my force F2x, and this is my perpendicular distance plus 40 sine 30 multiplied by 8. This is my force F3y, and this is perpendicular distance. So on solving this, so the moment at point A will be 273.13 Newton meter. So this will be the moment at point A. So just to recap, we have given the multiple forces and we need to figure out the moment at point A. So first we verified which force is creating the moment. So here this force is not creating the moment because there is no perpendicular distance. Then we find the component of F2 and we found that this is not creating any moment and only this is creating moment. Similarly, if you find the component of forces here, this will create a moment because there is a perpendicular distance, and this will not create a moment because there is no perpendicular distance. This is the parallel distance for this force, but perpendicular distance is this. Okay, but there is no perpendicular distance from point A to this force. So only this and this creating the moment. Then we define the direction, that the direction of force is this, then it revolves around in the counterclockwise direction from around point A. This is point A. Similarly, this also revolves around in the counterclockwise direction around point A. Then we use the Varignon's theorem that the moment at point A is the summation of all the moment from all the component of forces. And we use the Varignon's theorem to find the overall moment at point A. So any doubt? Okay then, so let's move to another problem. So it's a similar problem, but in this problem we already have given one external moment here. So here the bracket is subjected to 3 forces and a couple. So in a couple, what happens that, let's say you have a body. So in a couple, the moment is produced due to equal and opposite forces. So for example, you have a point here O and you have a force F here at point A. Then let's say the equal and opposite forces acting at point B. So here the overall forces are 0 because at point A we have a force F and at point B we have a force minus F. So the summation of force or the resultant force in this body is 0. Summation of forces is 0, but there will be a non-zero movement about point O, and this non-zero movement is there due to the different perpendicular distance. So for force this force, this is my perpendicular distance, which is, let's say, dA, and for this force this is my perpendicular distance, which is dB. So if dA not equal to dB, then there will be a movement, because according to the Wegener's theorem, I have force multiplied dA minus force multiplied by dB. And this will be the moment at point O which is acting. So in a couple, what happens? The summation or overall or resultant force is zero, but even if your resultant force is zero, there will be a moment, and this is a couple. So in the equation, we have given a three forces and we have given a couple. What is force F and where does its line of action intersect the x-axis? So you have this x-axis and you need to find force F. There is some resultant force F and the line of action from this x-axis. Line of action intersect the x-axis. You need to find this distance d and you need to find this force F. So as usual, let's define a point O here. This is our point O, and let's try to find out the moment. So since there are two unknown, you don't know anything about this force F, which is the overall resultant force, and you don't know anything about this distance d. So apart from using the moment equation, you also need to use the summation of force equation that we have seen earlier in the class. Because in the equation it is said that you need to find its line of action which is intersect the x-axis. So in the equation it is given that there will be there is a force, some unknown force, some unknown resultant force, and its line of action is intersecting the x-axis. So this is the information we have given in the equation, that so it could be here, it could be here, or it could be here, but it is intersecting the x-axis completely. So for this reason, we have assumed the direction of force like this. Well, you can use some other angles also. Let me use this angle. You can use like this also. Okay, let's use some. Okay, so let's randomly assign the forces then. Because we don't know anything about the forces, we don't know the direction, and in the equation it is said that the line of action intersect the x-axis. So it could be either this way and it could be either this way also. So let's say this is one of the component of forces. Let's say y component of forces, which is intersecting the x-axis, and there is some x component of forces which might be intersecting y-axis, but we don't need to consider that x component of forces because we need to calculate only this distance. Okay, so let's say this is the force. So we need to calculate the overall force and this distance from origin to the this line. So first let's use the summation of force equation. And the moment equation. So by using the summation of force equation, I can write Rx as summation of all the forces in the x direction. So here in this, we don't need to take the component because forces are either vertical or horizontal. So it will be Rx 400 minus 200. So it is 200 Newton. And Ry will be 180 Newton. Okay, so we know Rx and Ry. So we know that this force, which is Ry, is 180 Newton, because this component of force can only intersect the x-axis, and Rx will be intersecting the y-axis. And now we use the moment equation. We took the summation of moment about point O. So it will be due to this force. This force, because it has a perpendicular distance point 2 from point O. So the direction is this, which is revolving point O in the counterclockwise direction. Then the moment due to 400 Newton, it is revolving about point O along clockwise direction. And there is a perpendicular distance, which is 0.6 meter. Then we have already given one moment, a couple, which is 140 Newton meter. So we need to consider that also. Then there is a force, 180 Newton, and it revolve around in counterclockwise direction about point 2. So the couple is clockwise direction. From the figure itself, we can see that it's in a counterclockwise direction. So let me assign counterclockwise direction as positive and clockwise direction as negative. So I can take the couple directly, 140. Then this force plus 200 multiplied by 0.2. Then this force 180 multiplied by perpendicular distance, and for 180 Newton force the perpendicular distance is this, which is 0.65 meter. And then this force, which is clockwise direction, about 0.2. So minus 400 multiplied by 0.6, and it is equal to RYD. Okay, so RYD will be 140. So this is 40. This is 240 plus 117. So D equals 140, 180 minus, let me calculate this. So it is 57 divided by 180. So D will be 0.317 meter. So you can see that we use this moment Religion's theorem to calculate the unknown quantity D. So first we use the summation of force equation, Rx equal to summation of force in the x direction and Ry equal to summation of force in the y direction. We use these two equations here to calculate the force Rx and Ry. Then we use the moment equation, Religion's theorem, which says that the sum of moment at point O is due to the overall all the moments, and we calculate the moment from each forces here. So the every forces here is contributing to the moment, plus there is one couple is also acting in the counterclockwise direction. Then from this equation we actually get this unknown distance, because in the question we have given that there is a unknown there is a force which is acting, overall force which is acting, and it has the unknown distance d from the intersection point and the origin. So we have already calculated Ry, and d is the only unknown quantity here. So we use this Religion's theorem to calculate the d. So, any doubt in any of the problem that we have discussed, or in any of the concept that we have discussed, how to calculate the moment or how to calculate the component of forces and all. So there is still one more problem left here. It's a pretty straightforward problem again. And whatever we have discussed in this class, you just need to use the same concept here. So in this question, first you need to define the moment C. You need to actually calculate the moment or the couple at point C, and you have given the condition that sum of moment about point A due to all the forces and couple are zero. So the moment about point A, overall movement, I'm talking about the overall movement about point A is zero. So what you can do, you have a overall, you can use the Varignon's theorem. You just find out which forces creating the movement along point A. So this force will create, this will create, and this couple will create, and this force is also create movement. So this, let me consider this force first, 2 kilonewton, and the perpendicular distance is this 5 meter, and this is the movement direction, which is clockwise. I am taking clockwise as positive, and this is also clockwise around point A, plus 3 multiplied by 5 plus 3, because this is my perpendicular distance for 3 kilonewton. Then for this forces, again it's a clockwise direction about point A. So it's 4 multiplied by perpendicular distance is this 3 meter. And then there is a couple acting in the counterclockwise direction, minus C. And in the question it says that the moment, overall moment at point A is 0. So this quantity is 0. So this is equal to 0. So you have 2 multiply 5, 3 multiply by 5 plus 3, plus 4 multiplied by 3 equal to C. So you will get the couple here in the first part. Then you need to determine the sum of moments about point P due to the forces and couples acting on the bar. Then you just need to calculate the moment about this point. So just consider all the forces again here. Consider this couple also. Consider this couple also that you have calculated here, C, and all the forces, and use the same concept that we have discussed. First, define the perpendicular distance of all the forces, then see that which force is creating the movement, and then check its direction. Okay, then calculate the overall movement here. So it's similar to what we have done here and in the previous question. Okay, so just try to solve this question by yourself, and we will discuss this question in the next class. Okay, so in the next class we will be solving question related to the equilibrium. So the equilibrium concept is just extension what we have discussed today. So today we have actually see how to calculate the reaction forces, which is summation of the forces in the x and y direction. In equilibrium, what happens, this summation of forces or this reaction forces are zero, which means that if you have a body, let's say this is your body, and you are actually applying too many forces, this body is not moving, which means this body is in equilibrium, which means that the summation of all these forces is equal to zero. And we will be using this concept to find various unknown forces and various unknown movements. So in this tutorial, we actually try to calculate the overall forces and overall movements by using the Varignon's theorem. In the subsequent class, in the subsequent tutorial, we will be solving equilibrium problems where the overall movements and overall forces are zero, and we need to find various unknown quantities. So that's it for today. And if you have any doubt, yeah, I will upload the video and the PDF as well. So thank you all.
Hello.
Hello.
Sir, one more classes they are given in the mail from 5 to 7 like that.
Okay. Yeah, that class might be from other TA. So, I mean, I don't have any idea about that class. So, actually, multiple TAs are organizing the tutorial. So, and we are organizing independent to each other. Like, so you
Okay.
can, so you can, yeah, for more benefit, you can join the class and he will be solving more problems on the same concepts. So yeah, try to attend his class as well and see more variety of problems or the
So,
concept.
so this is that is a different TA is taking the different topic or the same topic.
It will be the same topic. So basically, we will try to take tutorial problems from that from the previous week. So I mean, this week is more about the summation of forces and movements. So we will be taking tutorial about the same concept. Next week, there will be a concept from the equilibrium. So we will be taking the tutorial for equilibrium, and we will be moving step by step. So
Okay, sir.
yeah,
Okay.
yeah.
Thank you, sir.
Thank you. Yeah.